Welcome to this session where we are going to do logarithms and exponentials. Our main focus will be based on converting exponentials to logs and also converting logs to exponentials. Let's begin. So I'm going to start with converting exponentials to logs. Exponentials to logs. The first example, let's say you have 4 to the power 2 is equal to, let's say, 16. Then you've been asked to convert this exponential into a logarithmic function. How can you do this? So what you need to do, you introduce log on 16. Then after you do this, the base still remains the base. The power is what comes here. Okay? So we're going to have log 16. Then the base is 4. So it will be base 4 is equal to 2. This is how to convert, as simple as that. Let's have another example whereby you have 2 to the power, 3 to the power maybe 7 is equal to 8. How can you convert this? Introduce log on 8. The base remains the base. So in this exponential form, the base is 3. So even in the logarithmic form, the base will still be 3. Then equal to the power is what we are going to equate to. So this is how to convert. Let's have an example. Another one. Let's say you've been asked to convert 10 to the power 6 is equal to 15. How can you convert this? You introduce log on 15. The base is 10 there, so it will still be the base. Then is equal to the power is what we equate to. So it's equal to 6. Let's have another one. Let's say you have 2 to the power 3 is equal to 8. How can you convert this into a logarithmic expression? So you say introduce log on 8. The base remains the base, so base 2 is equal to 3. So basically this is how you can convert exponentials into logarithms. Now let's look at how to convert logs to exponentials. So the opposite is just true for exponentials. When you have a log, let's say you have log base b, log y base b is equal to, which variable can I say? X. How can you convert this into an exponential form? So what you do basically, you take this b to be the base, then the x will be raised as a power, then it will be equal to y. So this is what happens. It's like a rotation. So what we have, y will still remain here, then it will be b to the power x. So this is how you can convert from log to exponential. Let's have another example. Let's say you have log 8 base 2 is equal to 4. How can you convert this into an exponential form? So you remain with 8, then this 2 becomes the base even in the exponential, then the 4 will become the power, so you've converted. Let's have another one. Let's say you have log 16 is equal to 4 and the base there is b. How can you convert this? So 16 remains like that, then b to the power 4. This is how to convert. Let's have another one. Let's say you have log of 20 of 200 rather, base x is equal to t. How can you convert this? So you take x to that side, then the t becomes the power, so you're going to remain with 200 this side is equal to x to the power t. Let's have another one. Let's say you have log b base a is equal to c. How can you convert this? So the b remains this side, then a to the power c. So this is how you can convert from logs into exponentials and from exponentials into logarithms. Let's now do evaluation. Let's say you've been told to evaluate a certain log. For example, evaluate log 4 in base 2 to the power x. How can you evaluate this log? So the basis of this mystery is just to know how to convert a log into an exponential. Once you know that, it will be very easy for you to evaluate even a logarithmic equation. So what you do, you take that 2 to the other side, so it will be 2 to the power x is equal to 4. Now what you can do here, you just apply the laws of indices. So you can raise this 4 to a certain index such that the bases will be equal. So you can say 2 to the power x, converting 4 into an exponential, it is 2 to the power 2. The law which says when you are multiplying base indices with the same bases, you maintain the power, you maintain the base and also add the powers. But there's another one which says when you have maybe a to the power b is equal to a to the power c, when the bases are equal and they are equated, meaning that even the powers are equal, so it is safe to say b is equal to c. So that is what you're going to apply at this stage. So what you're going to say is, since 2 is equal to 2, meaning that even the powers are equal, so x is equal to 2. How can you evaluate another one? Let's say you have log 16 base 2 is equal to y. Find the value of y. So you do the same. So it will be 2 to the power y is equal to 16. Which number can you raise so that you convert this 16 into an index? So 2 to the power y can also be written as 16 as 2 to the power 4. So since the bases are equal, meaning even the powers are equal, so y is equal to 4. That's very simple, right? So let's have another one, a bit challenging, whereby you have log 81 raised to the power 1 of third is equal to, let's say, is equal to x. How can you evaluate this? So what you can do, okay, so this is what we can do. So you can take this to the other side, so it will be equal to 1 over 3 to the power x is equal to 81. So what you need to do here is to change this 81 into the multiples of 3. How many times can 3 be multiplied so that you get 81? So this is what you need to know. So 81 can be written as 3 times 3 times 3 times 3 times 3 times 3. That is 3 to the power 4, right? 3 to the power 4. So this is what you do. So it will be 1 over 3 x is equal to 81, can also be written as 3 to the power 4. Let me get rid of this. Okay, so what we have is 1 over 3 to the power to the power x is equal to 3 to the power 4. Now you can express 1 over 3 as 3 to the power negative 1, just from a law of indices, which says when you have a to the power negative 1, this is the same as saying 1 over a, just the inverse. So this is what we've done here. Then of course we have x there to be equal to 3 to the power 4. There's another law of indices, or exponentials rather, which says when you have a to the power m, then everything raised to the power n. This is the same as a to the power m n. So this is what we're going to apply. So you just multiply the indices, that is negative 1 multiplied by x, so it will be 3 to the power negative x is equal to 3 to the power 4. When the bases are equal, so should the powers be. So negative x is equal to 4. You equate the powers, you find the value of x by dividing on both sides by a negative, so x is equal to negative 4. So this is how you can convert exponentials into logs, logs into exponentials, and also evaluating logarithmic equations or expressions rather. Thank you for watching.